Okay, today I'll talk a bit how we do things in Posti. Posti is like one of the main logistics company for parcels and delivery in Finland, but also we have quite a lot of sub-companies in the whole Baltic. So there is also Posti Messaging, which is one of the sponsors, and then we have in multiple. And I will try to be a bit quicker because we're behind time, but anyway, I hope that you will understand. Now the only thing is that I'll have to scroll like this. So, does anybody ever remember agendas? Because personally, at least, I don't pay attention. But how do we go through things? First, I'll tell you a bit about Posti, because I believe that in order to understand why and how we do things, you need to understand the scope of the company, organization, development teams, infrastructure, and maybe services. It's essential to what we talk next. So the problem, what we have, and then maybe the solution we came up with, even though, of course, no solution is ideal. This is some quote I stole from a colleague of mine's presentation. Don't worry, I didn't copy the whole presentation, but he was talking about platforms, and our infrastructure is kind of a platform to some extent, in a way that it centralizes all our services, but at the same time decentralizes like responsibilities and decentralizes applications, segregates them, and gives them freedom. To start with, maybe a bit about myself. Currently working as a head of software. Originally, by profession, I'm a software engineer, so not exactly have been working all my life with infra and DevOps stuff. I've been mostly around front-end, back-end. At the beginning of my career, I also worked like a bit with those old Hyper-V, VMware, whatnot, physical servers. Then switched to AWS, and today basically I would say I'm half of my time, or more than half of the time, managing the teams which we have at Posti and the engineers, and this of course includes partially not coding, but then I still get some time to code from time to time. Tech-wise, I've tried many things, but this is maybe the most recent what we are doing at Posti. So tech stack is like front-end, TypeScript, React, GraphQL, Apollo. Backend, we have microservices, so it's a bit more diverse. I've been touching only the Python, but we have Java. There is also some Clojure, and that's as far as I know. And then all of it goes on AWS as our infra. Now, the important part, in my opinion, I'm not showcasing Posti in a way to like when you go to student days and companies try to attract talent. This is just for the purpose to understand how huge of range of services we have and what we have to deal with when we build the infra, because Posti is building some kind of service, some kind of products, and then the infra is only, well, I wouldn't call it one entity, but it's centralized. So we have in total like 21,000 employees. I think this is from last year September data, so current one might be more or less here. Not all of those are IT obviously and software engineers. We have a lot of operations, a lot of drivers, logistics, warehousing and whatnot. So obviously software is somehow connected with all of them, but not everybody is software engineers, thankfully. The owner of the company itself is the state of Finland, so it's a publicly owned company, but then again it's a group of companies actually. It's Posti Group, and then we have sub-companies in the whole Baltic pretty much. In some of the countries we have development teams, like here in Riga and also in Estonia, but in some we don't. In Sweden, for example, there is no development team, there are just one or two system specialists. What we do. The name I believe is quite close self-explanatory, but in total, and again, these numbers are, let's say, might deviate a bit, but we have around more than 3,000 service points. So when I say service point, you can imagine a locker box in some supermarket or some company or something where you can put parcels and letters and whatnot, where you can pick it up later with some code. Per day we have around more than 7 million postal items sent, and you can scale this. Let's say if every item has at least 5 events, that produces like billions of requests and whatnot per day. So it's quite a heavy scale of data we get and transactions and whatnot, which we need to process in the software. Yes, otherwise we care about carbon neutrality, which I must mention. And then we visit more than 3 million households and companies like every weekday. Again, the scope. It's from transportation to warehousing, sorting, and then to delivery last mile. All these 4 areas have some kind of software. Of course, I can say that everything is customer facing. Let's say warehousing, most likely the customer never sees, but in the background there is some software, some algorithm, something tracking all the parcels and whatnot. So there is quite a lot of software. More numbers, I promise this is the last. In total, so the software in Posti is handled by this so-called tech hub organization. Of course, because it's such a large company, you need to have some layers corporate. In total, we're around 160 software engineers. Each one of them is, let's say, good at something different. It can be front-end, back-end, infra, full stack, whatnot. Everybody does something different. So we have some development team in Tallinn, which is 3 teams in fact. Then we have in Riga 2 or 3 teams. In Finland we have throughout the whole country, but the headquarters in Helsinki, where we have around 90 people. This is how the tech hub looks like. So digital development is where we focus on the developing all the digital services. Platform and tech ops, this is the part where the infra is maintained and all the platforms and everything which is supporting that digital development. And then starting, well, maybe even in the past we have been focusing on security, but starting last year we also extracted information security in a separate unit because it's an important topic and big concern, so we are investing a bit more into that. Now, finally, to the problem. As you saw, many countries, many services, a lot of employees, a lot of events, like 7 million parcels being sent, and then each parcel producing some events and whatnot, and you need to store the data, status of the parcel. Then you can imagine those are parcel boxes, they're IoT, so connection gets lost, some request doesn't arrive, some data is missing. There are quite a lot of problems, which unfortunately, of course, we don't have solution to everything. But one of the main problems was how to organize all those teams. We have more than 50 different teams working on different services. And when I say 200 services, those are running services. So I'm not saying some service which is a single payment and then it's an endpoint. No, this is like a service with multiple endpoints and multiple functionalities. A service is, let's say, payments is one service, and with payments you can imagine how many things there are, integrations and whatnot. And in total we have, not all of those are active, but in total we have more than 1,000 repositories, because literally every team, whatever they build, everything is either a micro frontend, microservice component, so we try to modularize as much as possible. So all of this, how do you manage it in a easy way? How do you scale it? Let's say, obviously these 50 teams weren't there since the beginning. Maybe started with 10, then 10 more came, 10 more. Eventually some teams, stop working on the product, so you need to kill the service or try to scale it down. So it's a living, not organism, but it's a software is like a living being. It grows all the time and it changes, so you need to adapt all the time according to that. And I'm not even starting about some integrations which we have to a lot of companies, external partners. obviously you need to track then about all these services and things and whatnot. You need to find a way to manage the costs. You need to find a way to track business processes, to map it to business organizations, because in a huge organization obviously you will have multiple cost centers and whatnot, and then you need to map which service goes to what, so it gets really, really complicated. And last but not least, maintenance, security, logging, all of those things are like, you need to support them, otherwise production doesn't work without them. But let's start directly to the point. I picked some random picture from the internet presenting what I think, don't take it in a way if you hear it at your company, please, that it's bad. So simple infrastructure, in my opinion, doesn't mean less experience compared to complex infrastructure. If you're working on this, it doesn't mean that you're less experienced compared to somebody working on some huge chart. It depends on how you build it and what quality it is. So what do we have here? Some users, some gateway, I don't know, API, then connects to some VPC, it can be AWS. I put AWS Cloud, but doesn't matter, it can go in Google Cloud or in your local. There's some database, probably something fetching, maybe a router if you have some different endpoints, REST APIs, whatnot, GraphQL. Pretty basic, right? And this would serve maybe a single application, maybe few applications if you have services. If you have one team, it works. 2 teams, also maybe it works. But then more than 3 teams, let's say, how do you manage access? How do you track changes in the database? How do you... It gets complicated. The more it grows, from user's perspective, the more harder it is to track this and to manage and to control it. Let's make it a bit more complicated, since we mentioned, and sorry a bit for the blurry picture, but this was the most appropriate one and I can explain it. So let's add some availability zones if you want to provide your services in multiple regions, or if you want to make sure you're backed up if something fails, then it switches to another availability zone. Let's add some logs, even though I mentioned the logs already. We can add some CI/CD pipelines. I would say it's quite similar to the previous one, but then again, we have, let's say here, one application, another application. So if you go here, you can see some admin tasks, app services and whatnot, and then private subnets, and it gets a bit, let's say, more complicated. This could work again. Then again, let's say if you have the need to add another service here, or another. What happens then? Do you like copy paste this? Then how do you connect it to the database? What if you need to create more databases? From the CI/CD perspective, what if you need more pipelines? What if you need more environments? So let's say development, staging, production. I would say all of that is missing here. Let's go next. Again, similar to the previous one, but maybe a bit more availability zones, some more private subnets, and then let's imagine there's some load balancer at the beginning in case you have more users. What else do we have? Fargate, so it can be Docker, it can be anything. You need to, put them in some containers if you want to deploy them. And then at the bottom we have the CI/CD, so it can be anything. It can be GitHub Actions, it can be whatever you want to build your pipelines with. Again, quite simple. It could scale. You could add more. You could create EM roles for everything, policies and whatnot. This could work, and I mean, probably does work and does the job for most of the time. But again, what if you have 50 teams? Again, you will end up in the hassle with the roles. You'll end up in some hassle, and I'm not even touching here like environments. It doesn't matter. You can have your environments as you want, but you will end up in problems like how do you track? I don't know. How do you track which service? How much cost do you get out of each service? Like let's say how much is the DB, how much is the Fargate, and then how do you track them on a service level and on a team level and maybe on a unit level, because most likely every unit will have multiple services, so it gets tricky. One more scale up. And this is finally something a bit more meaningful with multiple teams. So let's say we have here 3 engineers, 10 engineers, 5 engineers, I don't know, some multiple teams. And I'm not sure why they're so blurry in my laptop, they're not, but let's see. We can check the presentation later when we upload it. So we need to have some kind of, so these are, imagine that these are different like environments, and you need to track for each one of those. The services inside don't really matter. It can be, again, Lambda, DB, what is the here, API gateway. That one has some RDS, CCA, EC2. It doesn't matter. Every service can be different. Then you need to somehow consolidate the billing, account management for all of these. How do you create new accounts, delete old accounts, employee leaves, you know, new employee joins at the positive side. So how do you do all of those? Probably you could summarize all of them somehow and then have some central root administrator account, which is, you know, like the main one, and then for all of this you could create sub accounts, and then everything goes to this one. And you could probably do this for every service separately, or for every unit, or for every group of applications, maybe. It could work. But how do you, in a big organization like Posti, I often get asked what is the cost of, I don't know, development in X or this and that service. Let's say we have Posti. What is the total cost for Posti as an application? And Posti, trust me, it integrates to like payments, it integrates to more than 15 services. So payments, users, accounts, what else is there? Tracking, sending, so quite many. And if I were to have somehow aggregated billing for each of those separately, I would have to go to every single infra, get the costs, and then go to the other and get the costs, and then I would get, only then I would need to, you know, manually calculate them and then get the Posti costs. And that's just one example, but what if you have, I don't know, 10 applications like Posti, and then you need to report at the end of the month, then billing, tracking billing is like, it gets really tricky. Another thing is who actually maintains the AWS. So we saw here we have multiple teams, but who is responsible for the whole infrastructure? So if you have some infrastructure as a code, who maintains the repository, who is taking care of it, updating, whatnot. Of course, all of this can participate, but usually, well, we cannot expect that all the software developers are skilled with AWS, so you need to make sure that there is support. And okay, you could argue that you could put a DevOps team, infra team. Yeah, I've been told not to say DevOps because apparently the infra people don't like when they're called DevOps, but maybe somebody can tell me why. Either way, you could put like an infra team who supports all of those, but what if you have 50 teams and then infra team needs to support, like, create their environments, build everything for them? That's like, you would need a really big infra team, right? So somehow you need to, our idea was that somehow you need to have an infra team, but at the same time give responsibility to these teams, that they kind of take ownership of their infra, their own infra, even though it's not their infra, it's in the background, it's Posti's infra. Back to the problems, and I'm checking the time, okay. Okay, history I mentioned, but then if you have infrastructure as a code, I expect that you will have some history track, so that's good. And then, last but not least, different needs. You can imagine that if every team here has some different service, most likely somebody will ask, hey, how do I create an S3? Another one will ask, how do I connect to DNS? And then some other engineer will ask, my pipeline is failed, so please help me. So there will be needs which you cannot ever predict. So, how did we solve it at Posti? Has anybody here heard about landing zone? Do you use it maybe in your company? No? Okay. So, it's a, I'm not sure if the concept is new, but landing zone was, okay, I wrote you the definition, I won't read what's a landing zone, but it's basically, the idea is that there's a environment which is well architected and that it provides support somehow that you have a root user. So starting point, and then all the other things are connected, multi-accounts and whatnot, and environments, multi-environments, and everything is connected and controlled through this root user. This would allow you to track for every single one how, whatever you want, like what is running there, how is it built, costs, which we mentioned many times. It would provide you maybe even for a baseline how to start, because if it's always the same, maybe there is a pattern which you could reuse and reuse and reuse. So this landing zone was introduced like a... Okay, let's start from the beginning. I wrote dark old days, but maybe I'm too young. I started somewhere like with this Hyper-Vs, and I remember when I started my career, I was going to some server room during the night, and you had to, because you know you couldn't remote access control, so you had to go in the room and then restart the server, because the person responsible there tells you that no, it works, it's on, but actually it's not on. So I won't start from there, but I start from where we started at Posti. We had a single AWS account, which was like the admin account, main account. We had some production, development, staging, testing. I don't even remember, it was too long ago, but I'm pretty sure we had at least 2 environments. There was production, development, and then testing for testers. And they were split with some VPC. Of course, for those you need some EM roles. We have some EM roles and policies, access rights. Now the billing part. Can you imagine how we were doing it? At that time in AWS there was nothing. So what we were doing, we were adding tags to every single resource we created. Let's say it's an S3, we add a tag, I don't know, there was a number, some magic number, 735, I don't know, and then that's how we were tracking. So every single resource which was 735 was connected to Posti, and then we were just checking at the end of the month or whenever we wanted, okay, what's the cost for all the resources for 735 or whatever I said. And at this point I wrote infrastructure as a code beginnings, but probably the idea was before there, and let's say we started thinking about how to put it like in code, not just manually click, create and whatnot. This is where we started. Going next, we went to some multi-accounts, so there was not a single account, but we were creating separate accounts for dev, production, whatnot. There was one admin account linking all of those multi-accounts, and the billing was consolidated to the admin account. Everything was manual, so new team arrives, we have a new service to start. We were creating everything manually, and of course there were some scripts that you run the Python script and it creates it, but it was still manual. Then this is where it starts. re:Invent 2016, Amazon is introducing AWS organizations, and this is probably the beginning of this landing zone where they brought the idea that, hey, let's make something which is well architected actually, and which would allow you to scale up, scale down, and diverse no matter how your organization is. And they were offering automated account creation, automated account deletion, policies and whatnot, rules. I would say at this point there were quite a lot of scripts, so nothing was in a way that you have a template and then you run it and you have it magically. There was nothing. You had to write a manual script, and that was the automation at this point. But going next to the landing zone, 2018, landing zone 1.0 is released. What's this? It's basically their first solution for landing zone for all of these things which I was mentioning before. So logging, accounts creation, security, EM identities, and most of it was like practices, but also based on a service. So for the first time ever they offered actually, let's say, a service, a way to architect it. The problem with the first version though was that it was really, everything was based, okay, do you know what CloudFormation is? Have you heard about it? Okay, so it's infrastructure as a code, you write a template, YAML again, you have seen it, and then you deploy it somewhere, and then Amazon is smart enough to read it. So everything was written in CloudFormation. The problem was that those files were really, really huge. So if you had to make a change, you had to scroll through thousands of lines of CloudFormation, and well, maintenance was really hard. And last but not least, rollback. Let's say you deploy something by mistake, rollback through it was really hard. You had to, there was no easy way to roll back your deployed template. You couldn't just say, hey, delete the last change from Git and then deploy this previous one. That was, you had to manually change it. Then AWS landing zone 2. Well, did it happen in the same year? I don't remember now, sorry, I should have. But I think this happened at the beginning of the year, and then 2018, they fixed it. So finally, they provided a way, yeah, it's 6 months later, so it's in the same year. They provided a way that, you know, all those 1,000 lines of code, you could now split them in a bit other way. They provided some templates for everything because there was no template. It was just one cloud, well, not one, but it was a huge cloud formation file. And here with 2.0, they provided separated templates for everything. So ECS, I don't know, Redis database, whatever, there was a template for everything. But the only problem was migration. If you started over there, version 1, and you wanted to go to version 2, it was a bit of a hassle, not impossible, but it was, let's say, quite hard to get from version 1 to version 2. Today we are here, they offer control tower, because this is, so 2.0 is still a lot of, you need to be really skilled and you need to be infra expert in order to write those cloud formation templates. So there was demand that to make it simple, so they started this AWS control tower. Control tower is like a hosted service which basically abstracts everything from 2.0. So it's basically 2.0, but you know, it's like click, 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 click something, and there are templates, and it's far easier. So you don't have to do. It's a managed service by AWS. No, we don't use this one. We are here in the middle because we want the flexibility, but it's a possibility, and you know, it makes your life easier probably. So, where is Posti? We decided to stick in the middle, like I said, so we're at landing zone 2.0 due to the fact that we don't want to depend too much on the AWS and we want the flexibility. We chose to go for a framework called Scepter, and most likely, I don't believe too many of you have heard. Has anybody heard about Scepter before? Okay. It's a library, tool, framework, I don't know how you call it, for a cloud formation template. So it provides a CLI, some basic infra architecture, whatnot, and then it's stateless. It has a lot of YAML templates already. It supports Python, so you can put some automation and whatnot. It integrates to GitHub Actions, which we use for CI/CD. That was important for us, and you have quite a lot of control, I would say. Even though, well, because I'm leading all the development teams for my developers, it's really hard to catch up to all the. There are a lot of technicalities, so you need to understand or indeed to really dive deep into it if you want to be good with it. So the learning curve is quite steep, it's hard, but once you get used to it, it's actually not that bad. You can say by this that I'm not that good at design, because probably you shouldn't put them too close for proximity, but this is how it looks. There is some config, everything is YAML in the Scepter. There are environments, so dev production. There are templates, and that's all. You can have multiple environments, so there can be testing, staging, whatever you want. You have some YAML config files, which you can also take from here. And basically what you do, you put them in the appropriate folder. Then when you run some command or some GitHub action goes through it, it just deploys all the templates to CloudFormation, and tada, magically you get all the updates in your AWS. They call them stacks, but stacks and stack groups, that's what they say. Scepter is based on stacks and stack groups, but what's a stack, what's a stack group? Basically, this is a stack group. Every environment is a stack group, and then stacks are the configuration files. Nothing too scary, I would say. This is some example, let's say, how do you create some subnets YAML. So basically you just run a command, they provide built-in commands, and then it creates everything, and it gives you like even low-level information about IDs, about whatnot. So this is how it looks like. This is what I was talking about. So I don't know, there is some config templates, blah, 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 Lambda scripts. I extracted this from our GitHub, so I can show you the whole thing. But anyway, we have 4 environments: dev, production, staging, testing. I took development just to show you how it is inside. So we have some app, which is templates specifically for the application. So basically we are starting something regarding an application. It can be, what can it be? Well, I don't know now, some routes or some whatever not. Infra is just initiating the instance itself. So let's say you need a S3, so it will be most likely here, just creating the bucket. But then if you're configuring something, deploying to the bucket, then it goes here. Migrations is just keeping the history, and then the config is for the, basically for the development environment. That's where you put all the configuration. If we go inside app, this is how it looks like. Everything is a template. So we have a Amazon MQ example, users, well that's not an example, but DynamoDB example. We have an example for every single thing you can create. And what the developer needs to do, go here, take the example, maybe modify it a bit, and then just put it inside the, well, it needs to be here actually. So you just change that .example into normal one, copy it, commit it to GitHub Actions with some pull requests, it gets deployed. How are we with time? I'm checking, it's good. And this is how it looks like. This is a basic DynamoDB example. I don't know what you have, some application name, let's say what's the service or application which you're creating, the environment, so is it dev, staging or whatnot. Was that some key? I have no idea what that key is. And then was that some backup, but those settings can be different for everything obviously. This is the template, and basically, of course there are more things you can add, but this is simple template. This would create your DynamoDB after it gets deployed. How does it look on organizational level, so Posti-wide level? We have many teams, as I said. It's around 50. I haven't counted them, lost count at this point. But let's say there's a Posti.fi team, there's Soma Posti team, blah, 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 till 50 teams. It doesn't matter, it scales so much that it's really easy to create and kill, not kill teams, create and shut down teams environments on the run. Each one of them can have one or multiple repositories, but what's important that each one of them has their own infra repository. So we have Posti Cloud Infra, we have Oma Posti Infra, yada yada yada, Team 50 Infra. So this infra repository contains all the settings for their own landing zone. Even though when you think about it, Posti it's just one account, but they are separated in a different landing zone. That's why it's called landing zone actually. So for example, Posti.fi will have 4 environments, so production, staging, testing, and development. Then the next one will have the same, the next one will have the same. It's always standard. It's up to the team, do they want to use all of them? It's recommended, of course, but I don't know, there are teams which don't need staging, for example. I don't know, some design system team, they just go development, testing, and production. They don't need the staging really because there's not some critical data. And then all of these, you can assume that all of this most likely will have to communicate at some point, exchange some data, because different services, you know. So in the middle we have API gateway called Link, that's how we call it. It's custom built, everything by our infra team. On behind it, in front of it, depends how you call it, we have AppSync, which is our main gateway. We are heavily relying on GraphQL, even though in the background there are a lot of REST services, and I don't even know, there are so many services which are old, so obviously we didn't rewrite everything in GraphQL, but they're REST. So AppSync is really neat because it can connect to anything. It can connect to a database, it can connect to REST endpoint, it can connect to, I don't know, even probably local server. I don't know, I haven't tried that. Then the other option is Kafka, which we recently started utilizing. The idea is that you saw how many events we have. Millions, billions per day, depends. Well, it's millions, it's not billions. So this concept of push and pull to AppSync, it's fine, but then when you have a large scale of events, maybe it's better to go for some event-driven architecture. So in a way that push all the events in some, you know, lake of events, what do you call it? Bucket of events, and then whoever needs the events or whoever needs the data can just subscribe to it. So that's why we started utilizing Kafka. Now, if you look a bit better in team level, so this is probably the same picture except that this is a bit more detailed. And then what happens? So again, application development team, it can be any size, any type of people, front-end, back-end, whatnot, designers, QA. They do their own thing. They have their own repository. They have 4 environments, so development, testing, staging, production. That's always like that. Inside their environments, they can pretty much start anything, whatever they need. It can be, as I said, ECS, S3. Okay, the routing is probably done by another way, but whatever. You can start pretty much whatever you need. Then on the side, that's the important thing. So, you see my mouse, yeah. So here we have our cloud infra team, which is single team, and that's why I said can a single team support everything. But in our way, because the application development team is responsible for the cloud infra, and the cloud infra team is responsible only for creating the basic, the template, the skeleton. So for this, they initialize it and then it's empty. You have 4 empty environments, and basically of course they need help sometimes, like how do I do this, how do I start that. So they are always there to support you, but they don't, if you need to deploy some new application, they don't do that. If you need to change something like, well, okay, if it's something complicated like, I don't know, memory out of memory something, and you don't know how to do it, of course, they will support you, but it works even with 50 teams, so it's not that many requests per day, let's say. And we have, our infra team is how many people? Maximum 10, I don't know exact count now, but it's maximum 10, and they're rotating throughout all, like, they have shifts every day. What's also interesting here? Well, pretty much that's it. So they have created, so for every environment they have, so let's say there is account for development, there is account for production, there is account for staging, and then, what did I skip? Testing, yes. So every developer gets his own or her own account for every single environment. This way you're not sharing anything. Security-wise, it's far more secure. So if somebody breaches into testing, they will not be able to access with the same account to anything else. So the breach is only in testing. So everything is separated. Everything is quite safe, I would say. Yeah, that's it. I think we managed quite well with time. So any questions?